guys, hope you're doing well. This is our last teaching video, so that's really exciting. So I hope you're as excited as I am, and I hope you're jumping for joy like these little bunnies. These bunnies are actually going to help us kind of demonstrate what we're moving into today. So today's lesson is all about solving exponential and logarithmic equations. For example, in the real world, we could have a situation like this. Suppose that a population of 250 bunnies, I'm going to use bunnies, doubles each year. How long would it take for there to be 20,000 bunnies? We're going to circle back to this. We're going to learn a few things and then figure out how we can solve this problem. But these are the types of problems that we might be able to solve with logs or exponential functions. So let's first start with exponentials. If I have two sides of the equal sign that has the same base, okay? So for example, if we look down here where my cursor is, if we have 3 to the x is equal to 3 to the 5th, x must equal 5. Because the bases are the same, we can set the exponents equal to each other. So if we look at this example here, the bases are the same, so therefore we can set the exponents equal to each other. So that's what I'm going to do. All we have to say is because the bases are equal, that 3 minus 2x is equal to negative x, and then we can solve for x. Okay, I'm going to move 2x to the other side by adding, so negative 1 plus 2x is just going to give me x, so therefore x is 3. Okay, but what if we can't write the two expressions with the same base? Right, 35, I can't write that nicely as 8 raised to some power, okay? You could think of 8 to the first power is 8. Well, 8 squared is 64. So we would be in between, we would have to have some decimal, and we don't really know that. Well, we can use our logs to help us out, okay? So what this is saying, if we remember how to rewrite a log, that this is log base 8 of 35 is equal to x. Okay, well now how in the world do we evaluate that? It's not base 10, so we can't put that into our calculator. We have this change of base formula right here. This is a way that, we can evaluate these logs using our calculator even when the base is not 10. Okay, so if we go back here, what this is saying, log base c of a, we have to take the log, and we're going to use base 10, we're going to use the log of a and the log of c to evaluate this. Okay, so scrolling back up, if I want to actually figure out what x is, I have to say log base 10, so I'm not going to write it, of 35 over log base 10, so I'm not going to write it, of 8. And now I can plug this into my calculator. Remember that you have your log button, right? So we're just going to press log of 35. And that's 1.54. Whoa, that's a 5. 1.54. And log of 8 is 0.903. Divide those things. 1.7. Okay, so in fact, 8 to the 1.7 power is 34.3, right? And we have some rounding in there. So we did that right. So this is a really good thing to hang on to, this change of base formula. Now you can either write it down in formula form or jot down this example, because I think this actually shows it a little bit better. You will be needing this as you move forward to evaluate some of these logarithms, so I definitely would write this down, and we'll be practicing that in these slides. Okay. All right. So what about this one? Now remember that we're trying to solve for the variable, so we're trying to solve for m. Okay. So eventually we are going to use some kind of logarithm because it's in the exponent. Problem is there's a 5 out front. So we have to deal with that 5 first. So in these, there could be some properties that you have to do first before you take the log. You might have to subtract something to the other side. You might have to divide something. And that's what we're going to do here. So I'm going to divide each side by 5. So I'm going to have 6 to the 3m is equal to 4. Now I can put this in logarithmic form. Okay, so now I can say that log base 6 of 4 is equal to 3m. Okay, again, it's not base 10, so we have to change the base. So I'm going to say that log of 4 over log base 10 of 6 is equal to 3m. I'm changing the base. If I plug that into my calculator, I won't write out each. I'm just going to do log of 4 divided by log of 6. And I get 0.77 is equal to 3m. Divide each side by 3. So therefore m, divide each side by 3, is 0.257. So if we were to plug that back into our equation, okay, if you multiplied that by 3 and raised 6 to that power, multiplied by 5, we should get 20, which is pretty cool that we can solve these by using our logs. Okay. We can also solve logarithmic equations. So let's say we have something like this. Okay, and before you panic too much, this is very similar to the exponential that we looked at on the first slide here. Okay, notice that when the bases were the same, we were able to set the exponents equal to each other. So let's go back now. If the logs and the base, if those are the same, we can set the inside equal to each other. Okay, because remember what this is saying. This is really saying 3 to the what power is going to be equal to this. Well, 3 to the what power is equal to this, and it's that power, right? We can set those equal to each other. Take a look down here. Log base 2 of x is equal to log base 2 of 7. Well, x must equal 7. So all I have to do is set these equal to each other since the bases are the same and solve for x. Now this is algebra that you all should know how to do. We'll subtract 4x from each side, and I'm going to add 2, divide by 5, and we get our x value. Sweet, you're solving logarithmic equations. Look at you. What about this one? Okay, this time there's no log on this side, so we can't just like set things equal to each other. But we can use our properties of logs, and we can use our exponentials. Okay, so remember when there isn't a base written, it's really base 10. So this is saying 10 to the third power is going to equal 10x minus 7. Well, we know what 10 to the third power is. It's just 1 with 3 zeros, right? Is equal to 10x minus 7. We're going to add 7. And we're going to divide by 10. And it's 100.7. Those are zeros. PS. Okay. So if we're given an exponential, we can always turn it into a logarithmic to solve. And if we're given logarithmic, we can always turn it into an exponential to solve if that helps us. All right. So the last thing I want to point out about this is you may have to use your properties of logs as well when you're solving, okay? If you have questions moving forward on that, definitely let me know, but they should be pretty straightforward using base 10 if we need to, okay? All right, so how can we apply this? Let's go back to our little bunny problem, our little multiplying bunnies. So we have a population of 250 that doubles each year. How long would it take for the bunnies to reach 20,000 bunnies? So you could sit there and say, okay, well, if we have 250, then the next year it's going to double, so that's 500, then it's going to double, and that's 1,000, and then that's going to be 2,000, and then 4,000. But that seems like a mess, right? That doesn't seem super fun. So we're going to first build an equation, and I'm going to use B for bunnies. So the bunny population starts at 250, right? And it doubles, so I'm going to multiply it by 2, every year. So that's raised to the t power, where t, that's going to be my years, and b is bunnies. My handwriting is so good, isn't it? Okay, cool. Now that we have our equation, and now we can kind of apply this and try and solve. It wants to know how long it will take for there to be 20,000 bunnies. So we're solving for t. So I'm going to put that 20,000 in for my number of bunnies. 20,000 is equal to 250 times 2 to the t power. Okay, and I want to solve for t. So the first thing I need to do is chop off that 250. So I'm going to divide each side by 250. Okay, and let's extend this page a little bit. So if I do 20,000 divide by 250, I get 80 is equal to 2 to the t power. Now this is an exponential that we just learned how to solve. We can rewrite this and say that log base 2 of 80 is equal to t. Now this is not base 10, so we can't just plug it into my calculator, but what we can do is change the base and say that this is log of 80 over log of 2. When we plug that in, okay, to your calculator, you do log of 80 divided by log of 2, and we get 6.3. So that means in 6.3 years, the population of bunnies will be 20,000, okay? So these are the types of problems that we can solve using exponential or logarithmic equations. All right, one more, I promise. We got this. These can also be very valuable in figuring out rates, right? So let's say that the amount of money in a bank account grows at a rate of 1.5% each month. If Kyle has $12.80 in his bank account, the amount of money, we're using A, after t months can be represented by the following function. What I want you to notice is the rate right here. We had to take this rate, 1.5, okay, and add 1, but we had to move the decimal point a little bit, okay? You won't be building your own equations like this. You might be building your own equations like the bunny problem where something doubles or triples each year. Here, all I want you to notice is that because the rate here, okay, is greater than 1, it's going to increase. If it was less than 1, let's say we had a 0.98, it's going to decrease each year. Okay, well, how can we use this? Whoa, I didn't mean to do that. How much money will Kyle have in his account after 1 year? So what are we talking about here? Here we're talking about time and after 1 year. So all I need to do is plug in 1 here. So if you're using the function, if we just plug in 1, it's just 1280 times 1.015, which is 1299.2. Okay, now you could have said, okay, well, we could have also, gone back to the original and just thought about it, right? If he has 1280 right now and it grows at a rate of 1.5%, I'm going to take 1.5% and then add it on. You'll get the same answer, okay? Well, now how long will he have to wait until he has 3,000? This is what we are going to then apply what we just learned. So if his total now is 3,000 and we want to solve for the t. Okay, so I first need to divide by 1280. So I'm going to take my 3,000, divide by 1280, 2.34. So 2.34 is equal to 1.015 to the t power. Okay. Now I can turn this into logarithmic form. So I know that log base 1.015 of 2.34 will give me t. Okay. Turn this into base 10. Log of 2.34 over log of 1.015 is going to give you your t. So let's see what that is. Log 2.34 divided by log 1.015, 57. Oh, I almost wrote years. What is it though? It is month. I was going to say that would be a very long time, right? Kyle would have to wait a very long time. But he just has to wait some months. So this is 57 months. Okay, cool. Okay, so you just learned how to solve exponential and logarithmic equations. The last thing I want you to do is log into Clever and work on that last assignment. We are truly in the home stretch, right? And all my runners out there know that like finishing strong is super important. When you come around and you see that finish line and you zero in, we're there. Okay, your EO10 test is going to be at the beginning of week 7. So week 6 ends on May 12th at midnight, that Tuesday night. So your test is probably going to be Wednesday, Thursday, or Friday, somewhere in there of week 7. Okay, then we're going to start reviewing for your final, and then it's like donezo. So we are there. Okay, all right, I hope you're doing well, and I hope I don't have to continue doing this in the fall, but we'll see. All right, miss y'all. Bye.